what ChatGPT does, and it's literally how the model works. It's very powerful as a source of creativity and inspiration, but it is still, in essence, the predictor of the most likely outcome.
Hi, everyone. Welcome to WIT, which stands for What I Think. We're talking today to Thomas J. Espel. He has a profession of, I'm going to tell you a little secret, that I used to want to be a quant, but then I realized I wasn't smart enough, so then that was that. I'm excited to bring him here to talk to you about artificial intelligence, and specifically in my discussions, I did not realize that it's a lot of statistical models, which is what I studied in college. So I'm excited to bring him here and talk to you more in depth and ask him a lot of really tough questions to see what he knows. And then we're going to talk a little bit about the future of AI. So let's jump into it. First of all, Thomas, as one of those classic 80s traders, had changed your name to Tom. Tom, welcome.
Hi there. Happy to be here. I'll try my best to answer your questions. But yeah, Tom is better. Tom is easier than Thomas.
So yeah, why don't we start with a short summary about like your background, and then we'll dive in further.
Yeah, sure. As you mentioned, I'm a quantitative analyst. Basically, I use math and I use computer programs to solve, weird or complex problems in finance, if I try to simplify it as much as I can. In terms of background, engineering, so actually computer science down to electronics. And then after I did some math, and that's how I ended up in finance. I worked in London, now in Hong Kong. And yeah, I've been doing that for a couple of years now.
All right, well, so tell me what your definition of artificial intelligence is.
You have two components, right? You have artificial, which means that it needs to be man-made and it needs to derive from, I would say, physical principles. And intelligence is a bit subjective. And I think that shows the contrast in that it is what we call intelligent now is very different from a long time ago. If I can give you a bit of some context, what we tend to see at the first form of artificial intelligence were looms, like the weaving machines before the Industrial Revolution. So that's, the 1700s. And that was artificial intelligence. Now, what we call artificial intelligence is very different. It's things like ChatGPT, it's things like, machine learning with neural networks. But yeah, if I were to define that, it's kind of this tension of, what we make, which is super objective, and also some subjectivity of what we find is intelligent and smart now.
Yeah, well, it's kind of like me, because when I started this, I was just wanted to know what it is. But sort of my question is even involved to dive further about, what really is it? And it seems like it's changing all the time.
It's changed a lot. But one thing that I think has remained constant in how we define it is, I think it's always something that comes with some excitement and some curiosity, right? Because it's science driven. And then you have a lot of fiction, and that has remained constant through time. Even though nobody really knows exactly, I think, how to define it, you always have this sort of, wow, what's the next big thing?
Yeah. Well, I think, most of us probably, our first introduction might have been the Terminator, and really what the end result is. That's the starting point. I mean, it's with us already. So.
Or Metropolis. So when I was in engineering school, we actually had a screening of that. It's a very old German movie. And from the first one, when you had a robot, I'm a bit of a geek, so I really like Star Wars. Like, they took a lot of inspiration from that movie. And it's already a movie from like the 1930s. And it's the same kind of pitch. It's like you have a robot. So here it's like a woman who's like, saving humanity. Bit of a different movie plot compared with Terminator.
I actually did watch Metropolis, so I could say I did. But let's dive into more with statistical models. For this talk, what I did was I asked one of my AI bots what statistical models are used in AI. And I'm going to rattle them off, and you can briefly mention what they are. You can say anything about them, but we'll just kind of go through them for fun.
Good.
Hopefully we don't lose everybody. All right. Well, here's the most simple one. Simple. Linear regression.
It's the most simple one. The best way to explain it is visual. You have a bunch of dots you put on a graph, and you're trying to draw a line that is as close as possible to those points. That's the main idea. But that one, we say it's foundational, because out of this idea that you kind of try to draw a line to connect as many points as possible, many other models are built on that idea and just sort of transformation of this idea.
Are we using correlation?
Correlation is a statistical measure of, how two different data set relates to one another. You have this idea hidden. It's especially how you're trying to assess how good the regression is. So maybe let's start with, once you have a model And once you've drawn this line, you're trying to understand, okay, how good is it? And so we have a bunch of metrics that try to define that. And then we might use correlation between, for instance, what's predicted and what's used as the predictor, as the input of the model. They're kind of related to a certain extent. The main correlation measure is called the Pearson correlation coefficient. It uses statistical properties on two distributions to try to see how alike they are to a certain extent.
Okay, I'm going to go to logistic regression.
As I mentioned, it's built on this foundation of the linear regression, and it's just a transformation. And I think most statistical models is actually this idea is that instead of using, say, the row points on your graph with a function, and once they transform, then you apply a more conventional regression. That's how we try to explain the idea behind it. So you have the logistic regression, you have a bunch drawn from that same concept. So anything, something regression would be this idea that just transforms the points.
Everyone listening, I have my cheat sheet. Tom is being tested here. Decision trees. This is now expanding, right? And the third answer was decision trees. So we've gone from line to kind of like a binary, and now we're talking about decision trees where it's multiple instances.
Correct. Decision trees, the easiest way to look at it is you have a bunch of nodes. So let's introduce that concept. A node is essentially it's a function. So a function mathematically is, in our word, real word, is like a vending machine. It's like you put a coin, you put a number, and you're going to get a can or whatever that comes out of it. That's a function. And a node is just the machine learning term that we use, the computer science term that is going to sort of encapsulate that function within. Decision trees is a function that might have multiple outputs, for example, yes or no, based on one input. And we call them decision trees because if you put them one after another, you can see how, say you have two options each time, it kind of branches out and it creates like a tree. Where I know they're quite used now is sometimes we put them in parallel and we kind of have like different trees are going to have different, sort of votes and decisions and aggregate them together. And many tree algorithms are based out of this idea. And you're going to have many of those trees in parallel. So random forest in one of them, ADA boost is one of them. You have a bunch of them around this idea. But that's where the tree comes from. It's this idea that it kind of branches out literally.
Okay. So we were talking off camera about random forest. Let's talk about what that is quickly. Apparently it's used in predicting loan defaults.
So about the prediction, right? Most algos can be used to predict kind of what you want. What random forest does is it's a forest because it has many decision trees. It's called random forest because I mentioned all those functions have inputs, and sometimes you're going to randomly select some inputs. So take this example of loan defaults. A tree might really focus on the location and the income of the the loan applicant. Another one will focus maybe, more on the postcode and, the age of the applicant. It's randomly assigned what these parameters are going to be used. But you have basically a bunch of trees, and out of the outcome of the decision of these trees, then you get your answer. Again, that logic is something you see across many tree-based algorithms. But you can see the creativity, at play. When you have many trees, we call that a forest.
Yeah. It sounds like it's so common that it deserves its own bullet point. Support vector machines, SVM.
The way I would try to explain this is, say you play chess and you got white and black pieces on the chessboard. When you start, it's like super obvious which ones are black, which ones are white. You can visually see it. Now I make you colorblind, or like you cannot tell apart which ones are black or white, and I tell you, try to guess which one is black, which one is white. Well, it's very simple when you start. You just draw a line in the middle of your chessboard. Now imagine that we mix them around, and it's a bit more complicated, especially when you're further in the game. SVM is just this idea of trying to transform, so to move the pieces in a predictable way, such that we go back to a very clear line that divides them. We call that a classification problem. And of all what you've mentioned so far, we got the regression problems and the classification problems. So SVM would be more in that category. It has some perks that make it super efficient. So it has the concept like of sort of a soft, I would say, frontier instead of like a really clear-cut line. But to really simplify it, it's always about how do I transform those points such that I go back to a simpler problem. So that's sort of this straight line.
Let's ask you about naive Bayes.
The topology, the nomenclature that is used to try to name them is always that we're going to claim what is the statistical method we use to make those transformations. Yeah. I don't have a better way to answer this one, sorry.
Well, their definition is sentiment analysis of text.
This is an application, right? But it's a classification algorithm. So it's going to tell you if it's like positive or negative. Sentiment analysis, usually we bag it into a category that is called NLP, natural language processing. And there are other techniques that are being used now, which are historically, it started with statistical, and then it built out to more complex, computer algorithms, neural networks. And that's, what ended up, being nowadays things like GPT. So that's kind of the progression from that.
Is that like feelings and we're measuring that? And that must get really complicated.
It is, but at the essence, I think if you look at things historically and how they progressed, I think it's a bit easier to understand it this way. So all the methods that you mentioned, all these statistical methods, is kind of the foundation over which more complex models were built. But in essence, what happened, in the 80s and the 90s is that they moved from what you mentioned here to more like neural networks architectures. And there was one model in particular in the 90s that's called STM. And what this one does is that the innovation is, once I have like a sentence or once I have like a bunch of words, I need to add some memory in how I process it. Because all the methods that we've mentioned so far, there is no idea of sequentiality. When we speak, you need to look at the subject and the verb and everything that follows in the sentence. In a regression, regressions don't really matter. It doesn't matter. You just feed a bunch of data and then it's going to fit the data to the model and then, it's going to give you an output. So this was the first kind of innovation. And you get the intuition like, okay, if I got that network of nodes that kind of say, okay, that looks sequentially at the sentence, maybe it's a bit better at giving the sentiment and also doing translation. And that was the first application that you had for these models. And after that, then, fast forward, the 2010s, you had another innovation that was, okay, maybe instead of having these models that build sequentially, we're going to try to have a model that's more efficient and which can look at the language in parallel. So that's called the transformers. Nothing linked to the movies. But that was the kind of the inflection point. And most of what you see now and the excitement, I think, with AI and, for instance, large language models, that is the inflection point. It's a 2017 paper that said, actually, there is maybe a slightly different way to do things in how we process language. And instead of being sequential, we're going to try to have some sense of attention. Attention is a technical word. It's going to try to contextualize the words and the context. And it's after that, you had more fancy models that were there. If you look at things as this progression, which is that you start to mimic the human, and then after you go to a more efficient way, you can explain the progression for pretty much all the models that we've mentioned before. We started by just the regression, which is, I'm just going to draw a line like if I were a human. Then we try to make it a bit smarter. Then we get through things which are way more complex, like SVMs, which are like multiple transformations that are actually really difficult to represent, but we are actually much more powerful.
Wow. Yeah. So I guess we've gone from kind of executional automation stuff to understanding.
Yeah, that's you can put it this way. So understanding is, when you think artificial intelligence is more the subjective part. Like, does the model actually understand? Has it got some consciousness? That's open for debate. What is for sure is that we went beyond the representation of language as a set of words, and it got the sort of that extra notch of this attention, this context around the words. So for example, the word model. A model can be a computer model. It can be, someone working in fashion. We understand this out of context. So we gave that awareness of the context to these machine learning models. And it's that awareness and how sophisticated this awareness is that led, to what we can see now with very sophisticated large language models, is that once you're at a certain level where you can represent in some shape or forms the connections between words, it gets way better at translating, for instance, which was the first application versus, previous models. Yeah.
Wow, it's becoming more clear to me. Large language models, it's really like they established a form of communication to talk to the computer.
Kind of, yeah. So again, if we're a bit nerdy about the history, it was all about translation. And that was for a very long time the most complicated problem you had around for natural language processing. Because if you think about sentiment analysis, which is, the example you mentioned, it's a classification problem. Like, is that person positive? Is that person negative when they speak? The intuitive way we had before, a long time ago, is we look at a dictionary and we say, okay, the words like more positive or negative. And then after that, there were other techniques which were, okay, we can now look at a sentence and we say that sentence is positive or negative. So we're going to give it a label. And you actually had a whole business of like people just like creating labeling factories where they would just have humans review it and give that. And the machine would like compare the sentence and the labels and make them as a sentence. That's one category of problem. And now it's way easier to solve. Now we have even more sophisticated problems. But very quickly, people figured out, okay, I can get something that's good enough to give the sentiment. So that's sentiment analysis. And then we move to translation. And the reason why translation leads to understanding is that if you look at languages, the way they're going to structure the sentence will be very different. If you translate word for word, it's not going to work. Even between English and French, which are, quite alike in many ways, it doesn't work. So that's why you have to go through that sort of semantics behind. But the key was really to understand that it's about giving the machine an awareness of the natural context of the word instead of of getting the machine to learn which word maps to another. And that was kind of the breakthrough in these transformers. But for the anecdote, when they were introduced, immediately there was another model that's called BERT, B-E-R-T. Basically, it's a form of transformers that got like super popular, and everyone switched to this. So that's when I was finishing university, and that was seen as kind of the future. And the models like ChatGPT, which are they're quite alike. They have a few technical differences. We can discuss them, but they were seen to be like the rogue ones. They were like on the side, and they were underperforming. And it's just like 2 years ago that suddenly there was this new version of GPT that was like super, super robust. And people were like, okay, wow, that model actually turned out to be, the actual next way forward. But what this also means is that maybe what we're discussing next year will be completely outdated because there is another model somewhere that people have forgotten about and that is actually much better. And then it would rewrite the narrative that I've told you, which is we went from this and this and that. It's really like a tree with many branches, and some branches, outperform others at different point in time, I think. And that's how you have to see kind of the progress, which is we can really say this is the narrative so far of how it's progressed up till today, but we never know which next branch sort of on that massive tree is going to work out.
Yeah, I mean, I'm seeing this list here. Are we still at the baby phase? Can I just have emotion but don't know what to do with it? And then there's K nearest neighbors, KNN, and then we finally get to neural networks.
KNN is kind of the easiest ones to explain. These ones are like the basics. The ones you mentioned, they don't really directly feed into current present architecture that we know of for those large language models. But KNN is this idea that, think again, we have this graph with the different points, and we say, how am I going to, again, transform the representation so that it's very obvious which points go together, which are the same category. It's called KNN because it's K nearest neighbors. So K because it's like the mathematical notation for how many clusters, that's the name of these groups we're going to have. And we're just trying to aggregate them with one another. But it's the same idea as the one we mentioned with regression. It's always about how do we change and transform the representation of the points that we have so that it looks more trivial and it's easier to compute. Neural networks uses this concept of nodes and functions, right? And you can see the pattern here is that with neural networks, we said, this is how the human brain works. It's got this little cell, these little nodes, which are functions. We call them activation functions in the neural network. We're going to feed information through these connections, through these cells, and we're going to try to get them to learn stuff. I wouldn't say that it's kind of each of these is like a mini regression, but kind of. It's the idea behind it. But it's just that by connecting them, it's as if we were applying another transformation. We went from regular regression to logistic regression. It's just another way we transform. The whole process of machine learning is how to represent the data and convert it in a way that makes it more trivial to process, in essence. And that's where the affiliation is with the most recent language models, GPT. The T in GPT is for transformers. I don't think we know exactly why they picked the name transformers, but it's still this idea that we're going to transform the representation of words and sentences into numbers in a way that a computer can create this context around the words and enable them to be processed, basically.
Let's finish these out. Anomaly detection in data. Well, humans, we always look for patterns, and that's quite interesting, that associations and things like that. I feel like a lot of this is sort of associating that and creating a model around it.
Correct. I think most of the ones you've described, now I think most people will kind of jump directly to neural networks for pattern detection. I work in the financial sector, but broadly speaking, in computer science, either people are going to go for very simple models because we call them robust, they're very well understood, they're very easy to explain to other people. So that's all different shapes and forms of regression, classification. So you mentioned KNN, for example, is one of these classification systems. That's one box. Or you're going to go for very sophisticated and advanced ones. When you feel you need to go, for example, pattern discovery, this is where you're going to use much more advanced models. And this is when neural networks are going to step in. There is one statistical method that's called Kalman filters, for example, that was very popular at some point, but now many applications have moved to neural networks. So it kind of shows you now these sort of two sides, with one being statistical methods, but like the simple one, and then the very fancy advanced neural networks and things that go beyond.
Hidden Markov models.
Hidden Markov models.
This is an example is like speech recognition, time series analysis, and sequence prediction.
To be honest, Markov models, I've not encountered this one before. For the topology, though, like the name it's named, Markov chains is this idea that you had the memory sort of in your statistical process. So I would assume this is a model that discovers those Markov relationships, but I've not used that one before.
And the last one is Bayesian networks.
Bayesian networks, the way I would try to explain it is kind of the mishmash rehash of what we've discussed so far, which is that you're going to use those Bayesian models as blocks, and then you're going to put them as a network. That's how we try to define them.
Well, it's interesting to go through this. This is the kind of the general synopsis of what the AI produces. Maybe my current bot maybe it's a little old too as well. So I remember you saying that there are much more common models that you use all the time. And so what are those? Where are we at now?
So it goes back to what you're trying to achieve, and you kind of get an answer through, through your little sequence of the different models is that we tend to either use, I find, the very, very simple ones, or we tend to use the much more complicated ones. And that is because they will fulfill a different purpose. If you have an application that is critical, and critical in the sense that you need to really know how it's going to turn out, you need to really have a granularity, a level of detail in terms of your understanding of how the model behaves, you're going to go for the very simple ones. Linear regression, the plain, simple, blank, vanilla linear regression, I think is actually going to cover you for like most applications you can think out there, because we can already go ourselves as humans or as model designers, or just call it how you want. We can make all the simplifications so that it ends up in a model that is very robust and that's very simple and straightforward. So I think it's still the most popular model out there, to be honest. And the idea behind it is the one that then propagates to every other model that you have. And then you have the super fancy and advanced ones that will be for things where we don't really know how to make these transformations ourselves. And that's pattern recognition will be some of them. Because if we have a very clear idea of what to look for in the data, we would always try to use the simplest possible model. And if we have no idea, this is where we use the very complicated ones. And I think that's the process which through people go. And then you look at the very complicated ones, neural networks, in general, I think it's kind of the preferred use you have nowadays. And then, there is always a debate of where, neural networks start, what is an actual neural network, what is not, what is statistical methods. Some people say it's the same, some people disagree. But, you have a few networks we can kind of go to for specific applications. So time series, LSTM, that's one that you see a lot. Feed forward, that's one of the most simple neural network. The perceptron also is another very simple one. That's the ones you would learn at school, for example, when you start programming at university. And then you go for things which are much more complicated, which will have, some loops inside. You're going to have some which have specific cells. You're going to change, I mentioned each of those little nodes in the network, each of those neurons has this function inside, and you're going to tweak the functions that you're going to have. You're going to make them bigger, but it's all that same idea that it's either you go bazooka with your network, or you try always as much as you can to get the simplest one. And that's maybe how you can, I think, really differentiate what is more applied, I think, in the industry and what is more in the of research and experimental, is that you have this obsession to try to go to the most simple one at every point in time.
Well, now that we've kind of established and talked about the different models and what's more common and what's not, let's talk about what something most people are interested in is how to get rich off of using AI to trade equity. So I was talking to my cousin a couple months ago, and he showed me this trading site. The reason why this question pops up was because, shout out to Johnson Chang, I saw your talk at Johnson's get together of AI and business. You were talking about different sets of data. And you mentioned as a bucket of a type of data, there were 4 buckets, and you can explain those. But, one was looking at tweets as well. I don't know, perhaps that's just using correlation, but, maybe perhaps there's other statistical models that you're taking into account, because maybe there's more sentiment in that and analyzing that. But I think my first encounter was when my savvy cousin was showing me this app, and they had AI built in. They have their own sort of trading platform for stocks. And one of the things you can do is kind of click on a stock and see what percentage of whether it'll go up or down or not. He put in a stock, and I thought it was really funny because it was like 50% up and then like 50% down. And I was like, well, that doesn't help.
I'll tell you something that's a bit cheeky, if I may, is that imagine someone really finds a model that is 100% accurate to predict, where stocks or whatever financial instrument is going to go. Do you think they're going to put it on the website?
That's a good question. Their pay model is interesting. You have to pay into it, but then they guarantee that you'll make back the money. Maybe it's still not worth it, or maybe we're not there yet.
Maybe to give a bit of context, right, and where this whole, model and finance comes from. There was this guy, he passed away last year, Jim Simons, who's kind of the grandfather, of like modern computational finance. So finance It's quite broad. Within finance, you have a niche, which is quantitative finance. This is where I work. It's at the intersection of, mathematics and finance. And you have another part, which is computational finance, which overlaps a bit with quantitative finance, but has a much greater overlap with computer science and obviously is within finance. And so this guy, James Simons, his life is fascinating. Like, to anyone listening to this, just look at his life. The guy has like a super smart PhD in physics. At some point, he took a break and he went to Latin America to sell tiles or something like that. But anyway, the guy was a real genius. And eventually, he just started to ask himself, because we start to see data in finance that can be understood by computers, can we plug in a computer that's going to try to make sense of this data? And he created a fund that's called Renaissance Technology. People know it as Rentech, it's said to be the most successful fund, ever created. But for sure, it is the one that started to show that it was possible to use computer methods, so statistical methods, and then, more advanced, machine learning methods to make money out of, financial markets. Obviously, they never really said how they were using the models and which models they were using, but they were working. That's the thing, that's for sure. When he started to do that, that was like decades ago. He was a bit like of a weirdo. People didn't think it would work, and people were not comfortable with the idea of relying on models to make investment decisions. And I think that was enabled because of his mindset that, coming from a scientific background, the main idea of the scientific theory is that a model or a theory is deemed right if we can use it to make predictions. Every method we've discussed so far, its ability, in essence, is designed to understand a statistical distribution and to be able to replicate it. And we make the underlying assumption, we call that stationarity first time series, that the general properties are unchanged and therefore we can make predictions. We can understand the distribution in a way that is good enough that we can create new points from that same distribution, therefore being a prediction. It's very counterintuitive if you think about it, especially for something that's, like commerce in general. And finance is part of that. But because he came from that, scientific, background, I think he was more geared towards that approach to say, okay, a model is just a theory of how the market works, and we can just tweak the theory. Obviously, because it was widely successful over time, and as computing power was more available, you started to have people being trained in quantitative finance, and it's very easy to convert them from quantitative finance to more computational finance. Then those methods became more popular. But you needed to have this shift in people's mind that I can trust a machine to tell me when to trade. If you look at how people thought of trading in the 60s and the 70s, it's the Warren Buffett style. It is value investment. It is by analyzing, fundamentals. You don't look at price as a signal, as a distribution of points. So that switch had to happen in people's mind. And if you look even before Warren Buffett, you have, I think the book is called Reminiscences of a Stock Operator. It's almost like intuitive. It's like you look at the tape. So the tape is like the record of the transactions in the United States for stocks. And it's almost intuition driven. So you had a lot of things that need to happen in people's minds to reach this stage where you can start to trust the machine. And then, it's always about, trying to put it in the context. When people were more comfortable with that, and when you start to have people who were well trained to do this is when the age of quant, like modern quantitative finance, was kind of really born. And that's the early 2000s. It's only after that when you had more people who said, okay, we know this can work. And then they start to, to create models. And nowadays it's almost like a race. But what we've noticed also in the meantime is that at the time of James Simons, they were the only guys doing it. And there is this concept in quantitative finance, which we call capacity. And capacity is this idea that if many people do the same trade, have the same idea, pick up the same pattern, and they're going to trade the same way, you cannot have too many people doing the same thing. And if I want to give you some intuition about that is, for instance, every Tuesday, the supermarket next to where I live is going to have discounts in the morning. If I'm the only person going there in the morning, I can have everything discounted. If everyone in my building notices that's the case, I better, be really sharp at opening time. If the whole city notices that, there is no real advantage to having this information. And it's the same when you make a trade. And that's this concept of capacity. What this means is that it kind of negates a bit the idea and the predictive power unless you have that edge, unless you're always ahead of everyone else. Having this information, to your example and to your cousin, is I don't know about the specific website or whatever, and put all the disclaimers that apply for how to trade. But it's always this idea to say we only start to see a lot of them now because we had all these changes that need to happen in how we approach investment.
Yeah. So if everyone has a tool, then the market remains efficient. I mean, how much volatility is there right now because of all the changes in AI? Is it still because, let's say, ChatGPT opens up or OpenAI or any of these bots or platforms, they're accessible to everybody, is it still an even playing field, or how many market makers are there?
Before I answer that, I'd like to touch on what ChatGPT does and what those models do. I think what's really important to understand with ChatGPT, which is a type of GPT model, like BERT models, but especially GPT models, they come from these transformer architectures we've discussed. It's always about context. So in essence, what ChatGPT does, and it's literally how the model works, is that it's going to predict, for instance, for language, and it was designed for language, it's going to predict the next likely word in that context. So if you were to ask ChatGPT in the current form they are to design for you a computer model that's going to trade, it's going to give you, by construction, the most likely construction given its knowledge. It's very powerful as a source of creativity and inspiration to see how it may sometimes stumble on combinations you did not expect. But it is still, in essence, the predictor of the most likely outcome. So if you put it in the context of, I want to have a very novel idea that no one has thought about, does a model which was initially designed to predict the most likely thing, is literally how it works inside the box. Is it the best way to achieve that? Sometimes it hallucinates, sometimes it's going to create things which are a bit random, but it's still a predictor of what is the most expected in that context. And that's this attention concept that was introduced with transformer structure. It is a level playing field because if you have a specific idea of how to code things, it's very powerful now at just, writing you computer programs. But in terms of the ideation stage, when it might be used, and I think of creatives, in their work, how they use it is more like to bounce back ideas, because it's not a machine to do things which are novel in the sense of never done before. It's always about recombination. Now, if creativity is about recombination, that's another debate. But we need to start from that if you just give it a prompt, create me something, it's unlikely to come up with something, that will give you that alpha and that edge. That's one aspect. Trading, you still have strong barriers to trading, right? You need capital. So you need people to sponsor you. You need to have, enough cash. I don't think you're going to walk to a bank and then say, hey, lend me some money, I'm going to trade with it. In most countries, it's actually forbidden, and people should not do this. So you still have those obstacles. So if it's a level playing field, it would be more a level playing field between actors which already have some, capital. And I think where it is right now, it could be more playing field, in terms of, staff, hired to write some code, or staff, hired to check existing code and find bugs and all of these things. So in that sense, yeah, it's a level playing field. But again, in terms of the ability to design novel systems and to generate new ideas for research, I'm not sure. We see applications which are really exciting, is how it can be used to summarize complex market information, especially if it is non-numeric, like reports, that kind of thing. It just makes this information more available to people. But then the argument is, when you look at a market, you mentioned market efficiency. Market efficiency can be really strong, it can be weak, and it just depends on what level of information people have access to. So you can argue that it kind of makes market more efficient because potentially market participants have better tools to access all the information available at a given point in time. Now, in terms of volatility, so volatility is basically how your price jitters, right? Volatility is a bit like a fractal. So this fractal is this thing that is like a crystal. The more you zoom in, the more stuff you see. The link with fractals is that it depends always on the time horizon at which you look at it. So does the hype around artificial intelligence create more volatility on the equities market? If it's just news and information, I think they're always news and information. And we're at the time where you have a lot of headlines that create volatility, I think. Is there some specific types of volatility which are induced by algorithms written with large language models? I don't know. But again, I would doubt it, because I think at this stage it's more likely that it's going to be algorithms that use algo code and concepts which are already in the public domain. Because again, GPTs are machines that predict the next most likely thing when they write text. So when they write code is the same. They're going to do the most likely thing, likely being what's already out there and known in the body of knowledge used to train those systems.
More often than not, are there alerts or analysis from the AI? Let's say, for example, a government or a large influential person makes a statement on the internet. Do you normally have it where the bot or the AI makes a decision for you? Or is it commonly an alert, or an extreme alert? Are there levels of alerts to then for a human to make a decision based on the information?
There that goes back to where you see models which are at the edge of research. So the very, very complex ones, or if you have a very, very simple model. I think whenever you have a system that is the ability to make a critical decision, so that can be trading, that can be, in manufacturing, that could be decisions around, how to shape, different parts in a production line. These ones will always be, I think, very simple model, or what we deem simple, what we deal the least intelligent, on that spectrum of artificial intelligence. Because it goes down to this idea of model accountability, and it goes down to this idea of robustness. And you have another parameter, which is speed. If you have a very complicated model, it's going to be slower. And especially in some, time critical industries, so finance is one of them, media is one of them. When it's time critical, you need to think about stuff that go quick. It's unlikely you're going to have something super fancy and super complicated. I would imagine it's more like kinds of alerts that are going to pop up. It's more like, tools that are going to help you to make decisions, but ultimately it's going to be a human that makes decisions and makes that call. When it's things that are really well understood, when it's things which are more simple, so maybe not a celebrity tweet, but like quantified information, then you might have systems that can make decisions automatically based on the outcome. We have evidence in the public domain that we have models that look at financial data releases and that they're going to make decisions based on these releases almost immediately. These are regressions, basically, or forms of regression. So more people are comfortable doing that. Now, it does not prevent anyone from using a super fancy model, very complicated, and to wire it, as you described, to speech, or maybe a news feed, maybe they directly plug it to a TV and just try to analyze in live what is being said there. Then the question is always, if it goes wrong, who's accountable? That would prevent, most financial institutions from doing it, because there is this degree of accountability to regulators and everything around that. And also, I think if you have investors, so if you don't manage your own money, you need also to explain to investors why decisions are being made. So I think it's possible technically, but I don't think it's too prevalent at this stage.
Well, I'm sure the question is posed to you in your industry, like, is your job going to go away because of all this AI?
It will, because the job is going to change, but it will 100%. The way it's done now is going to be completely different, I think, in 5-6 years' time. And it's already changed a lot from the past 5 or 6 years. The current form of the job, which, involves, looking at mathematical books and, looking at reports and looking at information and processing it and theorizing some stuff and then writing some code, that part is going to go, probably. A lot of it can be automated and will change. But it means there are going to be other problems that we're going to have to attend to, right? But that I don't think is specific to my job. That I think is most jobs in the services industry. A lot of the tasks that we have, we're going to have very different tasks in the future. So in that sense, the current form of the job is going to go. But I think that's most industries. And it sounds scary, but I think it's actually quite exciting to say, hey, we're going to have other stuff to do.
Yeah, a friend of mine just posted about testing out like headshot photos, and he had a very hard time doing it, but he didn't have a good photo to begin with. It's what it sounded like. So, garbage in, garbage out, but you still need the underlying foundation of expertise. Like, I don't think that'll go away from the human element for the training, but of course, not everyone's going to make it either. I think there'll be, this will be a meritocracy. Do you feel that way? Will meritocracy prevail more? Like, if you're good, then you're always going to have a place?
I want to put trust on the expertise thing, because the expertise is going to change. If you look 30, 40 years ago, the way we define expertise is changing a lot. And I think that, for a very long time, we thought an expert was knowledge. And what the internet did is that it basically made knowledge a bit overrated. Now, what we define as expertise is kind of a level of understanding, a level of articulating parts of knowledge, because we know that we can Google it, we can search it. Mention, for example, different models. If I don't know about a model, and there are so many of them out there, I look them up in a book, I look them up online. So I think it's a bit naive to think that the expertise as we see it today is going to be the same vision we have for expertise in it. What that means in practice for very complex models, and we've been discussing about large language models, something you start to see already is that even though everyone will have access to the same tool, everyone will have access to ChatGPT through different means, shapes or forms, or different variants like DeepSeek or whatever, the way you phrase the prompt is a form of expertise. Because how you're going to prime the algorithm, how you're going to phrase the question is going to be a form of knowledge. And arguably, that is a new field of expertise, but it's a very different type of expertise. So it's a bit like you're saying, oh, do you need to be able to do math, to do computer computer science, yes, you need that. But the level at which you need to do math, I think now is not as much as before, because you have so much more you have to learn that's very specific to computer science. And it's this kind of idea that expertise is going to be distributed to other areas. So I would not be surprised that when I studied quantitative finance, we had a lot of, complicated equations, and we call them stochastic processes. I would not be surprised that in many areas of quantitative finance, especially already now, we start to see this in universities, actually. We will focus less on these, except you're going to go in a part of finance that really focuses on that. And we're going to spend more time explaining to you how do you train a network. So it's always this idea that expertise is going to shift. And so back to your question about meritocracy and if AI is going to be a level playing field or not, yes and no. Yes, there are many skills and tasks where it will kind of redistribute stuff. But it does not mean that you will still need to have an edge on some form of expertise. And that expertise could be how to properly use AI, or it could be which tools you're going to have to use in certain situations. Because we already start to see that even these models, the large language models, we need to specialize them in some shape or form. And I think it's quite interesting that it all branches out. We've got all these different models, we have them super smart, but actually what's happening behind the hood is that we start to see them building expert models. And I think it's going to be the same, is that we're still going to need some expertise. And in that sense, whether we make this expertise available to people or not to learn about it, to be trained properly, that's a broader question. But that's more a question of how we train people and what vision we have on how we're going to upskill people for this next industrial revolution.
Well, it sounds like in training people, it's not finding the people who have all the answers. It's people who know how to ask questions or have a lot of questions.
It's a bit back to the basics. The fundamentals of science is Greek philosophy, and it's all about how you ask the question. I would argue that's not changed. Maybe we had a bit of a phase where we think science is about knowing as much as we can, but it's often about asking the right question that's more important. So maybe it's a bit back to the beginnings at that stage, but I think it's quite exciting. Yeah, I'd agree with that.
I'm glad for this future because, like I said, I have no answers. I know nothing, but I'm good at not knowing and having to be like, what is that? More specifically, as I should, in a prompt. Tell me what you think about the current industry trends that we're living in. You can touch on anything like DeepSeek, Grok 3, and Grok 2 being OpenAI. I'll leave it to you about anything that, that's pressing in your mind that maybe affects you.
If we look at these models, I think there was a very important inflection point happening in late 2024, and that were models that were capable of reasoning. So what we call reasoning in the context of, large language models is that you can see that they can articulate steps in how they're going to process information. So it's no longer like you have one prompt and then you follow up. They can have multiple steps. That was a real breakthrough. So in my field, for example, the first version of ChatGPT and BERT models, they were incapable of having any form of mathematical reasoning. They could splur out some math, but they were not able to sequentially go through steps. And then many models were developed towards the end of 2024. And these are the ones that start to hit the headlines now in 2025, because they start to be released and start to be made available. So if I have to think at the single most important thing that's happened recently is that it's a race to these reasoning models that, they can do deeper research. And I think these ones have very strong potential of being transformational across many industries. That being said, if you take a snapshot of where the industry is, first there is obviously a geography and political element, right? We've got, the US and Europe is actually mostly French, United Kingdom and China. I think many countries now are jumping in, and I think that's going to be the case. And the reason is another way to look at where these models are is to think the ones which are what we call open source. So these are ones where you can sort of download the code online, or at least download the weight online. That's called open weight. And those which are closed, so proprietary. And I think this is more where we start to see sort of a divergence. And these are two very interesting, economic models. One is to say, our model is like the most important part, and we're going to charge you each time you're going to use the model. And another one is to say, we see the model as kind of a platform, take it like an iPhone sort of, over which you're going to build applications. And we're going to make money out of making sure you create this ecosystem around the model and sell a bunch of stuff around it, like how to train people to use the model, how to have fancy, computer chips that are going to run more efficiently on this model. I think it's more around that we should see how developments in that field are going to go. Open source models are great because they allow, first of all, the scientific community to look at what's under the hood. We mentioned now that we have specialized models, and then you have and it's all about how you distribute this expertise. It's called mixture of experts model. You mentioned DeepSeek R1, which is open source, is known to use this architecture. ChatGPT, we don't know for sure, but we highly suspect is using something specific. So with these open source models, you have a slightly better understanding of it. But then there is a question of where is the economic incentive to ensure that these keep being released? And it could be malicious incentives. Sometimes it's just you want to prevent a competitor from accessing the market and to be able to monetize. But that's the burning question. And then the other models which are proprietary, well, the economic incentive is pretty clear. The question is, if you have something that's like a black box, how comfortable will businesses be about using it? And I don't think that is going to be, settled. It's very likely it's going to go for a very long time where we see those two things evolving in parallel. And the best way you can look at it is operating systems. So your computer might run, Mac OS, it might run Windows, it might run Linux, and some are open source, some are not. And you still are in a world where, each of them has found their applications. Most people having their own computer will run on more something that's proprietary. So that would be Windows computer, for example. But most enterprise applications will use open source and use some form of Linux. So it's possible it looks like that. And I think to anyone who's just interested in how this is going to go and who's trying to understand, the news and the politics and all of that, I would encourage them to look under that angle, because from a technology perspective, and we have a history of similar innovations that went that way, it's usually more around that sort of fault line that things start to divide rather than, around geography or whatever. And it's also a broader question about where we want this to go as sort of a society. Do we see models as something that's commoditized? So something that you can buy a model, sell a model, like, for Star Wars, does it matter if you have a C-3PO of, this serial number or another? Or is the model the brand? Things like Apple computers. You get an Apple computer, you don't get a computer. And I think that's where I find this is a much more exciting conversation.
Yes, Steve Jobs, he's a big proponent of closed systems. How do you feel? What is your hope or vision?
They have all their pros and cons, right? I think we're still at a very early stage. So it's very exciting to see companies who try to put things open source, because it allows people who are interested about the field or excited about the field to try to use them. That I think is pretty cool. Now, if you look more from a security perspective and a safety perspective, then one of the problems with an open source model is that you can easily tweak it and manipulate it in a way that it kind of has no safeguard. So I can already see, the safety implications this has. And you kind of go a bit crazy and go wild. So I think sharing is good when you start, because it allows to have a broader conversation. And we're still at a stage where we're kind of educating people, and everyone is still getting educated to know what these models can do or cannot do. We don't even know how significant the change is going to be in our day-to-day lives. It could be absolutely transformational, or it could be just electricity, which is usually we say AI is to technology what electricity has been to energy, and we don't have to think about it. Many people say the end goal of AI is to make our interaction with technology very seamless. So we don't even know, is AI going to be at the center of lives, or is it just going to be like electricity? While we're still figuring out, it's great to share. But we need to make sure that we still put financial incentives to make sure that businesses want to drive that research. Because right now we rely on the generosity of very large corporations. We rely on excitement from investors who are going to pour money in those valuations. But it's too important of a field to not have research going into that.
Give me 5 to 10 year bold prediction.
First thing, most predictions went wrong right in the past. So it's a super dangerous area. I think we're still going to have this sort of dual approach, one with proprietary models and one with open source models. I can see businesses starting to, use those models in-house to try to see how they can fit within their operations. I'm not sure our world is going to be completely upside down, because it takes a lot of time to go and implement those changes. It takes time to get people to get used to these changes. And I will bet that there will be more regulation in some shape or form, because we're still at a stage where it's kind of a sandbox experiment. But the more that sandbox is going to start to bring in stuff which should not be in a sandbox, the more we're going to have regulators. So the EU, people joke that the EU is over-regulating everything, but the EU is looking at that, and they're looking at data. And it's hard for me to give you a vision for the next 5 to 10 years without linking back to data. And we go back to, regression and all these statistical models, and even those fancy language models that do the same thing. They try to replicate the distribution. Once the model has learned the data, and it's kind of one with the data. And I think there's a lot of work on what data is appropriate to train these models, what can be used, what cannot be used. And it will really depend on where the regulations go with data. If they start to say you cannot use your competitor's data to train your model, or things that could approximate your competitor's data, that will take it in one direction. If they say we need to make all the data possible available, that will take this in a completely different direction. And I think these first regulations, these first steps toward having some clarity on that, I think we're going to see them in the next 3 to 5 years. So in 3 to 5 years, I I think the debate will be again on data and how we use that. And based on the outcome of that debate, then we'll see how, prevalent these models will be, because it will tell how efficient these are.
So a lot of the gray areas will be more definitive in about 3 to 5 years, is what you're saying. And you feel like the EU is leading the charge?
I'm sure there will be more gray areas, right? Because I give you an example, actually something that's actually happening. It is said, I'm not sure, that Amazon is flooded with like new authors, which are just like submitting books written by AI. It's not human data. Should we train AI on that data? So internally, how many neural networks work, they're going to train themselves on data that they generate themselves. It's part of the training process, but it's a regulated, like it's a very controlled sort of environment. But then you will have this gray around, what do we do about data which was generated by previous models? Is it high quality data? Is it not high quality data? So, and this is going to be big. Already a big part of the conversation with DeepSeek is they use a method which is called distillation, which is something that's been used for a long time. I mentioned the BERT models. A very successful BERT model is called DistilBERT. And the idea is that you basically plug the output of a very intensely traced model that uses a ton of data, use that model, and you teach the other model on its output. And the idea is like, if you can mimic the output of a model that's really smart, even if you're dumb, then it's as good as if you are really smart, which is the point, right? You see how this gray area is going to explode as we see more people generating information, sound files, text files, video files with this information. So there's always going to be a gray area. For the main gray areas right now, I think the moment businesses will start to experiment more, then you're going to have more data generated, and that is going to put more questions. With regards to the EU Commission, it's cultural, and I can speak as a European. There is very strong emphasis on privacy in most European cultures. Privacy and how to use data has always been a focus for the EU. So that's why I think I can see how the EU is going to look at this almost for sure. Now, if other countries are going to start to look at it, I don't know. But for now, the EU for sure is kind of the leaders in that, because for cultural reasons, there is something that's called the Brussels effect, which is that usually when Europe starts to regulate, because they tend to set the highest standard, everyone applies the standard and they become like the benchmark. Maybe that will happen. But for sure, the EU is going to look at that.
Yeah, I will say that the quality control for movies is a higher standard in Europe. Surprisingly, I did not know that. In my movie, there were shots that were called out that you wouldn't notice, but they still called them out. So just even in that area, I can say, well, you're probably right. I may be able to look this up online, but like even forcing Apple to go USB-C or something like that, like what is it about the European Union, for example? Like how does their system work so that they can kind of team up to make people have a higher standard? What are they doing right, essentially?
First, the political system in the EU is hard to define. People say it's kind of a confederation because basically all member states through different, instances will have their say in how, you form regulations, how you're going to apply them, to which degree you're going to enforce them. So there is a culture of consensus. Now, why is the EU more prone to regulating than other markets? Well, regulation is usually something that happens with more developed markets because you tend to have more sophisticated products. And also the EU tends to import a lot of products. So they are in a position where they can be a bit picky with what they bring in and what they don't bring in. So I think it's this combination of factors. Regulation is inevitable, and that's something that we see in all industries, and financial sector is one of them. When you do things which are more complex, we need sort of a common standard. Now, is it, like a collective practice, like industry best practices, or if it is something that's enshrined in law, that's a cultural parameter. But even in countries where you have less of a strong regulation, especially common law jurisdictions, you will still have very strong industry practices and ways to do things and standards which are set by the industry. That bit is inevitable. Now, if it happens from a state entity or non-state entity, it's a different conversation. But when it comes from a state entity, it's very clear. It becomes very transparent. Whereas if it's like an industry best practice, it's a bit less obvious. For example, you mentioned Apple. In technology, you have a society called the IEEE, which is like a scientific association, and they basically set the standards for pretty much everything. There is no law in the world that say the Wi-Fi needs to be this specific type of component, but it's a practitioners association, and everyone kind of abides, to whatever they say. It's kind of an equivalent. So it's more a matter of how visible that is or not, if that makes sense.
Yeah. Europe has a lot of different cultures within it. So, it amazes me that system is able to agree on a lot lot of things, and also gigantic company like Apple to change its wires, which has been for the better of humanity, I think, because I think lightning cables.
The case for this one, it was like, that people don't have to switch, chargers all the time and whatever. I don't think, that's not the thing I would complain the most about, right? That you don't have to get one charger for every single maker or every single device. Yeah.
Thank goodness for the practicality all over the world.
If we were to apply this to AI, what would that look like? Would that be like, for instance, should we say image recognition models should be that type of neural network versus, I think you mentioned mixture of Gaussians or something like that, or should they be X, Y, or Z? Is that the appropriate level to which that should go? I don't know. I think it's still really hard for people to grasp what regulations would be like, to what degree of technicality those regulations would be relevant, which is why I really think it's going to start with data.
I'm in the camp of practicality. If it makes sense and it doesn't disrupt people and it makes people's lives easier, then, let's do that. I assume like the larger countries have more of an impact. So I'll say I appreciate, for example, German engineering and the skill, or maybe the design of the Italian, certain appreciation for different countries having their skill set.
That's an interesting one, because the type of skills and resources you need for AI are a bit different than from traditional industries. So you mentioned Europe, for example. Historically, Southern Europe was like, very rich, very prosperous. And then as the economies, turned more towards services, it went more towards the north of Europe because it was a different set of skills. It's an open question which countries will be the big winners in AI and everything which is linked to new technologies, because it potentially can be a very different set of skills. We don't know. Right now, I would say the leading countries, also the biggest ones, which have the deepest pockets. But we can absolutely imagine a future where, the UAE, so Dubai, can be even number one leader in that technology because it's a different set of skills. That also will be super exciting, because if you look at every industrial revolution, some countries have consistently been good at pretty much everything. So these ones, I don't think they're going to change.
I have this problem, differentiating specifically where Lego comes from and IKEA comes from. But, obviously Lego has cornered the landscape of toys for children that want to learn, but also fun. And IKEA has cornered the world for furniture. There you go. That won't be applied to AI in a way. Maybe that's how it's going, but maybe it won't even occur in Europe. Who knows? It could just be anywhere, but country specific.
There's some countries where it's very likely to occur. And we see this, and I go back, to quantitative finance. For a city to become a hub for these industries and technologies, you need a few ingredients, and they're well known. You need very good universities. You need research centers that may be or maybe not affiliated directly with universities, where you have theoretical research in mathematics. And you need capital. And that mixed together creates a financial center where you have innovation. So for instance, in quantitative finance. So the US, that's Chicago, that's New York, and now increasingly Miami. In Europe, that's London, that's Paris. Here in Asia, we have Hong Kong, we have Tokyo, we have Singapore. You also have Dubai, which is now an emerging center. You have a bunch of these right now. AI is a similar story, is that where do you have consumers? Where do you have universities that do excellent research? And where do you have those practitioners, but they still can do some theoretical stuff? These countries, the US, they obviously have the Silicon Valley. They have also the Boston area. In Europe, we have Zurich, we have Paris, we have London. Here in Asia, also, we start to see centers which are starting to pop up. So we kind of already get a clue because these ingredients are there. So I think Europe's going to be in the mix, but, the US are going to be in the mix. China's going to be in the mix. they don't change those ones. Japan, also, they're starting to gear up. So I think we kind of start to see the trend because it goes down to those core ingredients. So if these countries manage to sustain that momentum, then they're fine. But it creates opportunity for countries which are pushing really hard to create this ecosystem. They have an opportunity to step in.
Yeah, and maybe it doesn't even matter how large the economy is, or maybe the economy will be solely based on their AI.
I think that's totally possible. Yeah, absolutely. Because if you manage to attract talent, if you manage to create an environment where people can innovate, at some point you're going to create good products, right? It's just how it works. And that's the success stories of many places right now in the past 20, 30 years. That's exactly what has happened. They really pushed really hard and they got it.
What do you think attracts talent to a country?
First of all, when you talk about AI and these technologies, you talk about a very specific type of talent. So each of these talents is going to have, different stuff I think they're going to like. It's a very different talent for AI than for, I think, the movie industry, because it has different, I think, requirements. I think quality of life is something that comes up a lot because it's usually quite young people. So cities which are too expensive usually can be a bit of a drag. You need good research facilities. So that would be good universities where people, can go talk to professors. They can create, joint lab with companies, and it needs to be a business-friendly environment. So I think these are the main things. If you think about someone who's really ambitious, who's really excited about getting, in AI in any branches of the industry, that's what they're going to look at. Where can I not spend a fortune living? Where do I have prospects to grow and to learn as a professional, to upskill? Because this is a field that changes a lot. And where will I have basically people who can pay me decently enough so that, I can get started too uncomfortably in life. And once you get this mix right, then you see new centers that serve as spruce up.
If I were a teenager right now, what could I focus on?
It sounds a bit cheesy, but I genuinely think that's how stuff works, right? And I speak as an engineer by training. Find something that you find exciting, and it could be anything. It could be drawing, it could be math, it could be building your own computer, it could be whatever. And out of that, you can think, okay, how can I use AI or these toolbox for my specific problem, for my specific passion? I think it's the most natural way to get excited and to get into that field. But it needs to stem from something you genuinely like and to see this as a tool. And then out of that, I have no doubt you're going to do great things. Just open YouTube and you're going to see the amount of stuff that people do already is incredible, and things you would never thought of because they solve actual problems or they try to go further into something that they're already passionate about. And I think it's easier than to go through unless that's your passion, but to go through like the very theoretical bits.
So there's hope for us, for those who are less academic.
I don't see myself as too academic, just for the record, I would say. But yeah, of course. Yeah. At the end of the day, it's a tool. It's meant to help people. There is artificial intelligence, but it should be called practical intelligence, right?
Yeah.
Solving real problems. So absolutely, there is room for everyone.
And if you can do both, that's amazing.
If you can do both, that's great for you. But it's growing so complex that I think at some point you have to specialize. If you're a practitioner, you won't be able to learn and know all the models. You'll have to go for the ones which become the standard in your industry. And you're going to have to be really good at understanding how do I use them to solve problems in my industry. If you're more theoretical, you might lose a bit that direct connection with practical applications, but you can also focus on maybe more structural problems and have maybe a broader perspective over all the models. So I think you're going to have to make a choice at some point.
I feel like we still scratch the surface of what AI can do and where it's going, but certainly very informative. Definitely has helped me to develop a better understanding. I'm not sure which statistical model that is I'm using in my brain, but I'm just kidding.
I think what would be really exciting to get on your show would be people who are in the field of the pictorial arts. So, the people who are going to draw stuff, the people who are going to, work on branding, because there is this pitfall of thinking that, AI is going to go after your job, it's going to destroy everything you do, and people are just going to use a prompt. But the best parallel we can draw is, in the Renaissance, they would have if you go in the Louvre in Paris, you're going to see those massive paintings, and you're not going to have the guy who's going to paint every single detail. They're going to do some bits, the bits where they think they add value, and have all the people who help them around. And that I think is super exciting. Because it's not a question where the human creativity is and when it's not. It's more a question of how you can see those tools being used. Because I can give you kind of the hard, cold version of saying, okay, this is when you design an algorithm that is designed to frankly make money and a bit brutal, in the financial system. But if you contrast it with people who use it in a very different way, I think that'd be really cool.
I agree. I mean, the brushes will change. Thomas, thank you for your insight and all the knowledge you've shared. Thank you for joining me on the show. We've got to have you back.
There is only one message I have to tell people is that it might sound scary, it might sound confusing, but it's an exciting opportunity to get to learn new things. And looping back to artificial intelligence is a definition that changes through time, but it's always about getting that excitement. And as long as people are excited and want to learn, it's incredible what we're going to be able to achieve with that, regardless of the industry. And if there is one thing I have to say to people is get interested, learn as much as you can about it, because it's a new set of tools and it's going to be great.
All right. Well, thanks again. Thanks for your insight. And we're going to talk again. I know.
Pleasure.